The brown up in the Wyoming area you see there. Maybe up in the Four Corners, even a little bit of Colorado. Bituminous has been squeezed even more, so it's got even more energy in there. And it also has a little bit less water, less impurities. We're going in the right direction. And finally, anthracite. That's the good stuff. It's very shiny. Anthracite looks like graphite. You've ever seen that? There's a stuff in your lead pencil. Anthracite looks just like lead from a lead pencil.
Is that if I put it like more pure form?
I guess, but I don't know the
less water and less impurity to get more solid color.
All right, I'll buy that. You know, like carbon fiber is that shiny gray color, so maybe that's something to do with carbon. Anthracite is the good stuff. Anthracite is what you really want. Anthracite has been squeezed a lot, so it's got almost no water left. It's got very few impurities. It burns very, very cleanly. Of course, it's also the rarest. So these are your different coal types. This was some vocab. Some kids were curious which one is which. The things that you should know is they're kind of a spectrum. So we go increasing heat and pressure over time, increasing energy, decreasing water, decreasing impurities. Yeah. I don't know how formulaic it is, because if you can make a lot of heat and pressure in a little time, it would still work. You know what I'm saying? Yeah, exactly. So, like, if you're accumulating sediment, then more time means more heat and pressure. But if you're in a continental area where you have erosion decreasing your rock burden, then maybe it's a finite process that won't keep happening over time. Usually we say that in most places with the passage of time, the quality will increase. But I don't know if that's necessarily a number that you would know, like, oh, after this many years, it's going to be this time. I'll bet you the question is more about net pressure over time. Yeah. Okay. There is one thing I'd like to highlight, and we'll come back to this later, but I need to be really clear about something now. Many of us think of coal mining as like an underground hard hat with a light and like pickaxes and those cars.
It's not.
Yeah, the little cart on a little railroad track with the donkey and
a little birdie.
Yellow birdies, yeah. Everybody's getting to work, swinging their axes. I don't know how many of you were able to see the movie about coal 1 or 2 weeks ago, but anybody have a smartphone? How many tons of coal burn in the U.S. per day? Somebody else, if you're getting your smartphone out, the other question I had today, yeah, let's look at how many tons of coal burned in the world per day.
20 pounds from each person.
How much?
20 pounds from each person.
I still can't hear you.
20 pounds for each person.
20 pounds per person per day? Yeah.
In the world?
So we're talking 600 million. Anybody got another number that's clear?
Every hour of every day, the U.S. burns over 100,000 tons of coal.
Okay, so 100,000 tons per hour. I'm going to write that one down, 100,000 tons per hour.
I don't know how to do that.
Anybody got another cool number for me? I'm almost out of time. I really want to get a couple more of these. Anybody have something?
The amount of coal burned during 2007 is estimated at 133.179 quadrillion.
Quadrillion? in BTUs. So that's net energy content, not a good measure of coal though. Anybody else have another number? If anybody gets a good one, raise your hand or tell me after the period. If you want to post these to the Facebook group, I'd consider giving you points for the ones that are still interesting. My point is, when you think about pickaxes and like the little cars on the train, I'm pretty sure that we couldn't get 100,000 tons per hour from that sort of operation.
2007, 7.07 billion tons.
7.07 billion tons?
Yeah.
Okay. And that number's growing, by the way. That number's growing. 07 was not the biggest year for coal. I can't stress enough that coal extraction has become a totally different sort of business. How am I going to get 100,000 tons in an hour, and then get another 100,000 the next hour, then another 100,000 tons the next hour? We're doing this in a different way. We figured out that you can take a chain on the top of a mountain, drive it around with a tractor at the bottom of the mountain to scrape off all the vegetation and topsoil. Once you've made that into a clean cone of bedrock, you can drill holes and literally just blow off the top, scrape it, and now you've got a freestanding little cake of coal. And then you just drive up and scoop it. Well, I don't know, not my backyard, your backyard? Where do we have people that don't matter, otherwise known as the poor? Appalachia. Knuckleheads making too much noise. This is the main source of coal in the United States now. I believe the leading state is West Virginia. We're getting more and more coal out of the Rockies. You can see we've got a lot of it.
Wait, so that's like the second.
The other picture of
There was one.
coal cake.
I will show you some of these coal cakes later on. That's mostly by 2 minutes. And we'll talk more about extraction. But remember that we're getting into a very large scale. Okay? We've been trying to figure out how to hide the CO2. It's called sequestration. So when you burn it at the power plant, you try to drive it underground or mix it into concrete or find some way to keep the coal from going into the atmosphere. But one last little thing that almost escapes notice, coal extraction is one of the deadliest physical labor jobs in the U.S. And at 100,000 tons per hour, you know that we're doing a lot of it. There's a lot of miners, even if they're not swinging an axe, they're still in the tunnel driving the excavator. Okay. Let's see. In number 26 and 27, I believe these were already in your book. Maybe somebody can tell me who does their homework. Did your book talk about low sulfur, new boiler designs, scrubbing, and gasification?
Yeah.
Question number 26. Did anybody do this from the book?
Yeah. I have you for
Oh.
Yeah, scrubbing, gasification. Right, right. Yeah. Yeah. So students, if you don't do your homework, I'm not willing to lecture about stuff that's in your book, like number 26. I'll just make sure that goes on the test. Number 27, though, is the last thing I'd like to lecture about today. And then we get to get out of this out of conventional fuel. Tomorrow we'll start talking about alternative energy, and that's really what I think most of us want to think about. But before we get there, I've got one last thing, and this is a big deal. Raise your hand if you've heard about the Keystone Pipelines. Right now, there's this really sensitive political battle over whether or not we can import petroleum from Canada, put it in a pipeline all the way to the refineries, and bring across the United States landmass a giant inlet of petroleum. Canada, which coincidentally uses more electricity than per capita than Americans, and produces more trash per capita than Americans. They also own more guns per capita than Americans, but they manage not to shoot their children with them.
How would they manage
The
that?
children.
How would they possibly? I don't know. Okay. Isn't that surprising? I know. It just happened this year.
They're kind of
Bring them out.
You got the fish.
Yeah. Canada. Yes.
Well, how many people live in rural areas versus urbanized areas in Canada?
My hunch is even less than in the U.S. I'll bet you it's even more urbanized than the U.S. And this is all the surprising stuff. Canada has very quietly been following America's lead in many ways, but they're just a much smaller population of people. All right. So about Canada.
How Canada
I can tell that, like me, most of you have sort of assumed that Canada was in many geopolitical senses insignificant. But Canada is a rapidly rising political power, and they are kind of following in the footsteps of the American economy in most ways. Coincidentally, they also have giant oil fields, but their oil is probably of the lowest grade in extraction economics, meaning you got to do the most work to get their type of petroleum. You remember I told you, back in the day, we had our first peak oil for easy stuff, and we transitioned to keep producing more petroleum. We switched to new enhanced methods. We had to start adding energy, either water pressure or heat. Recently, it started to look like we're going to run out of that, so Canada is one of the places that's offered us the new future of petroleum. And I'm sorry, because it happens in so many places, and because it's kind of new, we still don't have a single name. You should know them. It's either coal shale, tar sand, oil shale, oil sand. It's some sort of petroleum word and some sort of geology word. So it's coal, tar, oil, shale, sand, or something else. In Venezuela, they call it extra heavy crude. In many parts of the U.S., they call it bituminous sand. And you can call it whatever you want. It is, first of all, energy intensive. You don't have to read all that other stuff. And it looks like that. If you're lucky, most of the time it looks like that. Now I want to make sure that we're all on the same page. You remember I told you, imagine how hard it would be to get petroleum from asphalt that's dried up on the road. Did we have this conversation?
Yeah.
Now we're talking about that. Look what that dude is holding. That's basically 90 to 95% sand. This is about 99% rock.